Welcome. In this particular demo, reasonably short one, we're going to have a look at animation. In particular, an implementation of the animation technique that we explored within the lecture. We'll see how we can implement that on a tablet device. Just a way of showing you the demo goes along with this. So if we run our animation test, we're going to have two animations that get to be played. One sort of a rough explosion animation, the other one a sort of a run and a jump animation. And they sort of iterate and continually loop. Just by way of showing you the source for these ones here. So we have animation 1 and animation 2. So the first animation, all of these ones have a number of fixed width frames, so they don't differ in terms of the width of the frame, but here we have the animation going in. And the second one, there's a bit more frames than this one here of just an individual standing, running, and then jumping. So all we're doing is playing back those animations by way of a bit of an overview about how this particular fragment works. And again, to reiterate, it's a simple demo. We've put everything together into one fragment. You wouldn't want to do that in terms of an actual proper game. You would have these separated out into separate classes, but for reasons of simplicity, they're all put here. So we'll have our game world that contains, in this case, the two animations that we want to play. We have our view object that we will use for drawing them to. And whenever we create this fragment, we'll create the world. And whenever we create the view of the fragment, we'll create a render view and return that. Now, I'll go down through this reasonably quickly. The animation class I'll come back to in a bit. And what we have down here is effectively the same content that we set out within the lecture. So that there's not much difference between the two. Our game world I'll come back to in a bit as well. I want to jump first of all to the render view, just to have a brief look at this here. In terms of changes, for animations we need some recording of time, because effectively we're using the passage of time to determine when we change the frame of the animation that's currently being displayed. So for this view, we're going to have, we're going to use long value, and we're going to have a measurement of time from it. There's different ways of recording time in different devices, and some of the mechanisms, well, all mechanisms of recording time will be accurate to a certain level. For games, it's important that we pick something that's accurate to the level of milliseconds, and not all time measurements tend to be upon devices. From a Java perspective, system.NanoTime is one of the better ones, so we're going to use that to give us a measurement of time. It will notionally record the number of nanoseconds that have passed, so it's 10 to the minus 9. It is nowhere near accurate on nanoseconds, but it is accurate at the level of milliseconds. So milliseconds is what we will be using. Now, if we divide the nanoseconds by 1,000,000, we'll convert it into nanoseconds. Nanoseconds divided by 1,000,000 will convert it into milliseconds. Ondraw method, all we're doing here is that we are working out what's the current time, working out, okay, how many milliseconds has elapsed since the last time we did it, and then sort of turning that into the elapsed time as a measurement, 0.002, for example, for 2 milliseconds. And this is what we will be passing in to our world, and then we'll be using that elapsed time, how much time has happened since the last time we called Ondraw, to trigger or to determine changes in the animation. So it's crude, it's simple. If you're doing an initial game loop, you would be recording and measuring time as part of that update, and you'd be passing in the elapsed time to your update and to your draw. So update the world. This will, and again, we're cheeky, we're doing this as part of the draw, but here we'll determine what is the current frame we're displaying, and we'll then draw the world where we will indeed draw out that current frame. If we have a look at our world then, so it's a little bit up here, all we have within the world are two animation objects. And there's different ways of doing this here. You could have an animated object. Alternatively, you could say you have a game object, and the game object contains an animation itself. For reasons of simplicity, we're just going to have two instances of an animation that we happen to be playing. It's quite possible when you look at the encapsulations and composition, that you would want to say that a class can contain an animation, and then when it's drawing itself, it would use that animation to determine how it does draw itself. Setting up the world, we're got 2 bitmaps to load in. We try to load in the 2 bitmaps. Having done so, we then create the 2 animations. In this case here, we're passing in the number of frames. These are image strips, and we're saying, okay, how many frames are within each of those strips? The assumption is they are of a fixed width. And immediately, we're not sort of waiting about, as soon as we load it in, we signify or suggest that we should commence playback of that animation. And the value here is just the number of seconds over which the complete animation will occur. So every 1.2 seconds we'll play an explosion. Every 2.2 seconds we'll sort of do the full loop of the character. So if I were to change this, for example, 0.4, and we were then to run that, it would result in the explosion animation then playing back at a faster pace. So you'll have sort of the explosions looking and playing back more quickly. Obviously, you're trying to pick something where it runs at a reasonable speed. Now, arguably here we seem to have crashed our tablet. I'm just going to get rid of it, and we'll create a new tablet and we'll let it run. Right. Okay, Virtual Device Manager, let me start a new tablet. We'll scale it so it appears on the screen, and we'll let that fire up. All of this just to see if we can get it running in a little bit of a quicker time. But it is important to see. Right, we'll let that carry on in the background, we'll come back to it. So these figures down here will control the frequency with which we play it back. When we're updating our world, we are simply going to each animation and saying, okay, here's how much time has elapsed since update was last called, and can you pick whatever frame you want to display at this point in time. Source and destination rectangle, we're down here into the normal drawing things out to the screen. And it's very straightforward here. We don't have these within a viewport. If you did have a world with a viewport, then you'd be factoring into that. First animation, we're going to have a method with our animation called getSourceRect, and we pass in a rectangle to that because we don't want to create more objects than not. So calling that, this method will populate this source rectangle with the frame that it wants to display. We're drawing it to a fixed size frame on the screen, and we're then sort of drawing it out. Doing so exactly the same with the second animation, asking it to overwrite source rectangle with where it wants to be drawn from in terms of the source image, giving its location on the screen, and then drawing the thing out. So hopefully this will be up and running now, and we'll be able to have a look at it. Possibly, possibly not. Let's run our application. And as a reminder for this here, if the thing runs, our explosion animation is now going at a faster pace. So we're running it back over a quicker one because we've increased decreased the playback duration on it. So the class that does all of the work is the animation class. Let's have a look at that one. And this is quite similar to the one we explored within the lecture, so I'll go over it reasonably quickly. There's a few little minor tweaks to it, and we'll have a brief look at those. So animation class, it assumes that it's drawing its animation from a single bitmap. This is set up to assume a horizontal animation strip. We can get the bitmap out if we want to. We have 2 private variables for the width and the height of each of the frames. So we'll calculate that upon construction. We know the number of frames that we have within the actual bitmap. And arguably, if you know the number of frames and the width of it, you can work out the individual width of each of the frames. But we're storing these here, so we're only calculating them once. We've got the current frame. So this is the frame of the animation that we want to display at a point in time. Depending if the animation is running or if it's finished, this could be maybe the frame at the start, the frame at the end, or for mid-animation it'll be some frame in the middle of the animation. A couple of timing variables. We've got a frame timer and our frame period. So one is the amount of time that we're into the current frame. So if say we've got 10 frames, we want to display it over a period of a second, then each frame will be displayed for 100 milliseconds. And this will count how long into the current frame we are, and this counts how long the iComplete animation should take. A couple of variables for telling us, well, are we looping this animation, and are we currently playing the animation? If we create a new animation, given the bitmap, given the number of frames, we sort of store these things and we work out the frame width and the frame height. We've got the play method. This is the one that triggers playback off it. So we're setting up the total duration for each of the frames by the period of the animation divided by the number of counts. So this gives us for each frame how long we want to take. So if it was 1 second and there's 10 frames, then that would be 100 milliseconds. The current frame we're setting to be a value of -1, and as indicated in the lecture, a value of -1, we use that as an indication that we've just started playback, and it's going to be our trigger point for getting the current time and recording the time and things like that. Are we looping? Depends what we say, and we say yes, we are playing. Update. This is where all of the hard work, and as far as it is hard work, it kicks in. So we check to see if we're not playing, we've nothing to do, we can return. If we are playing, then we're checking to see, okay, have we just triggered playback of this? If so, then the current frame will begin from the start of the animation, and we set our frame timer to be 0, so we've only started playback of the first frame. We update the frame timer with the amount of time that has elapsed since it was last called, and we check to see, is the frame timer greater than the period of time that we want each frame to elapse. If that's the case, we go on to the next frame, and we do a few checks here to make sure, okay, well, have we got to the end of the animation? If we are looping, let's go back to the start. If we're not looping, then let's stop this animation and set its playing to be false. Down here is where we have exceeded the duration of the frame, and then we take away from it the frame period. And we don't want to reset the frame period to 0 because we may overshoot it slightly, and we want to take this into account when we go on to the next frame. We've got our source rectangle. This is the bit that returns to the callee the region of the bitmap that should be drawn. So we check to see that, okay, we have a current frame. In other words, we actually are animating at this point in time. If so, we go to our base image and we're working out which portion of the base image, based on the current frame, that we want to display. So reasonably straightforward. All in, that's all we need. And this class here will give us a simple animation. You could make it more fancy, more extensible if you wanted to, but it is good enough to get the thing up and running. So hopefully of use.